Starting again, let's get rid of this stuff. Oops, I gotta click on there. Okay, let's try it again. There we go. Tell you what, let's keep that section 10.1 up there so we can see that. It is started. That's what I said. Thanks for paying attention. All right. So 10.1, let's do this. Okay, congruent circles. Watch this. That's pretty simple to see. If you had congruent circles, what do you think must be true about the two circles if they're going to be congruent to each other?
They must be similar.
Must be similar?
Yeah, similar.
They have the same radius. Very good. Okay. If these are congruent circles, let's call this circle A and circle B for lack of imagination. All right. So if these were congruent to each other, then they must have the same radius. Does that make sense? So if that radius, I don't know why I used 5 again. Oh, I didn't use 5 yet, have I? I used in my other class. I used it. Okay. So if I have 5 here and 5 here, they're obviously congruent circles. So I could say that circle A is congruent to circle B. All right. So knowing that they're congruent to each other means that they have the same same radius. For instance, if they did this, if they said they're congruent, if this was given to you, that the circles were congruent and it told you the radius of one, you could very easily find that. Now, of course, they probably won't get that easy, will they?
Yeah.
They'll probably do stuff like this maybe. So the diameter, I know, I didn't say it was hard, but I'm saying that. What if they said these circles were congruent to each other, the radius of A was 5, what is the length of CD? All right, so that would be pretty easy. What would it be? It would be 10, all right? That's simple, all right? Makes sense? It's just vocab is all it is. It's not really that, it's not difficult. Let's do another one. This thing is called concentric circles. Have you ever heard that word, concentric? Okay.
No, not really.
You haven't? Watch this. Now, to be concentric circles, let's stop with the comments, please, and let's listen, okay? If we have concentric circles, what we have are two circles that share the same center. Not radius, I almost said radius, but share the same center. So if I take this circle, which is significantly smaller, right? But if I put the center right on top of there, then guess what we have? We have concentric, let's write that down. Yeah, it's kind of like a bullseye. Bullseye basically are a series of concentric circles is exactly right.
The radius probably wouldn't be the same.
No, the radius wouldn't be the same.
Not like they wouldn't be the same.
But they don't have to be the same. I just did that because I just copied and pasted, and they happen to go in the same direction. They don't have to be. I mean, I could have, let's go to this. I could have done this. No, we didn't say it was half. Right, we didn't say anything. I mean, we didn't give you any idea of the relationship between this one and this one. I didn't say it's half or anything like that. I mean, I guess they could, but that's what we have. So these are called concentric circles. All right, makes sense? And I believe we have an example. No, we don't have an example. Let's go to the next. Let's go to an example, but they're not concentric circles. They're actually overlapping circles, and we'll deal with that. So let's get rid of all this mess. Oh, left a dot right there. Okay, and let's bring up a circle again. Now this is taken right from the example in the book, so you can follow along if you want. This one's a little bit smaller, about like that. They overlap. Actually, yeah, it kind of looks like those Venn diagrams, doesn't it? Actually, let's use this circle without the radius in there. Yeah. All right, so let's put that here, and let's put this one right here just so they overlap. All right, and let me get my line tool. And let's go from this to this. All right. And, all right. This point right here is R. This one right here is C. The little c. This one is D. And this is S. All right, so you got two circles, circle R and circle S. And what they're going to do, they're going to give you some information. Let me just read off what they tell you. It says the diameter of, let me write it like this. The diameter I'll just shorten it, of circle S is 30. It says 30 units, so inches, whatever. Say what?
Is that the symbol for circle?
Yes, we've discussed that. Yeah. Thanks for watching. Okay, so the diameter of circle R, Andrew.
Is D the midpoint of X and R?
Not necessarily. Can only go by what they give you. So is 20. And DS, well, they tell you a lot of stuff. So DS, the length of DS is 9. And they ask you to find what CD is equal to. I'm going to put CD equals question mark. All right? So let's fill some stuff in. The diameter of circle S is 30. So from here to here is 30.
No.
Did I?
That's the radius.
That's correct. I was just checking to see if you're paying attention.
Yes.
Not really. Right. Thank you for that. The diameter is 30, but what is from here to here, that little thing that I just drew? That's the radius, isn't it? So if the diameter is 30, what would that be? That would be 15. Thanks for keeping me on my toes. Now the diameter of circle R is 20. So what else does that? What would that tell us? That would tell us that RD would be 10. All right. And what do they ask? Oh, DS is 9. And they ask for CD. I kind of wrote over that, but from here to here, let's make that a little bit bigger, a little fatter. So that's what we're looking for, that thing right there. All right, that's pretty easy now once you drew all that stuff in there, isn't it? And really, did the 10 really even make a difference with this? Nah, I guess there could be other questions that they could ask for this, but which numbers are we going to use? Yeah, the 9 and the 15. This whole thing right here is 15. This little bit is 9, so what's left over? What is it? 15 minus 9, right?
But what about the bit of R?
What's that?
What about RC?
We don't really care.
Oh, okay.
Yeah, that's what I was saying. They gave you this to be 10, but that really didn't have anything to do with this problem at all. Now, not every time they give you information does it mean that you have to use it. In this case, we didn't really have to use it. I don't know if they do that to confuse you on purpose or not. I'm not sure what their thinking is. My guess is they probably do. They probably want you to think, oh, wait a minute, I got to use all 3 of those numbers. But you don't necessarily have to do that. So, of course, that's just 6. All right, so CD is 6, and that's all there is to that. All right, I've got about 2 minutes left on this video. Let's try to get everything done so I don't have to start another one. Keep that 10 there. All right. Let's talk about this. This is something you've been talking about for a long time. This is circumference. You remember the formula off the top of your head for circumference of a circle? It's not r squared. That's something else. Okay, this is circumference. It's pi. Yeah, it's 2 pi r. I'm going to write it like this first. I'm going to write pi d. All right? Pi times the diameter. But you probably learned it another way, didn't you? You learned it 2 pi r. But either way is fine. All right, doesn't make any difference. Now, how did you get from here to here? Well, look, twice the radius is what? Is the diameter anyway, all right? And we just like to put the 2 out in front. It just looks prettier that way, all right? So that's it. So those are your equations, or really, doesn't it boil down to really the same equation? It's really the same thing if you want to look at it that way. All right, so here's an example. By the way, I usually go through this whole thing. I'm just going to do this real quick right here. Do you ever wonder where pi came from? 3.14? Because look, let's do some algebra and solve for pi. If I solve for pi, what would you do? Get rid of the d. How would you do that? What'd you do? Divide by d. So what would it be? It'd be the circumference divided by the diameter. Now, we don't really have time to do this right now, but if you took a circle and you actually figured out what the circumference was, all right, and you divided it by its diameter, no matter how big or small the circle was, it didn't make any difference. Guess what you would always get? That's right. You'd always get 3, a little bit more than 3. Now, what I usually do, I usually have a cardboard circle, and I take a string and I wrap it around it, okay, and then get the circumference and hold it straight and measure that straight line. Then divided by the diameter, I'd have to measure the diameter of it. And every single time we've done it, we've always got a little bit more than 3. Now, with a piece of string and a ruler, do you think you can be as accurate as going 0.14 No, but you can get really, really close to it, okay? You can always get a little bit more than 3. Does that make any sense? Okay. Well, we're at 10 minutes. I think we've covered everything we need to right now. You know how to work with this. It's just plug and chug. It's pretty easy, all right? Okay, so
Bye, Internet.
I would put your assignment on here. Oh, I'm going to have to go to another. I don't know how long they're going to let me go.
Yeah.
They let me go a little bit longer
Yeah.
than, I'll tell you what, I'll just take a chance, yeah. We're going to do section 10.1, obviously, and it's page 687 and 688, and it's 10 to 35. And I'm going to shut it down. I think I should be
This lesson
good.
is quick.
All right, say bye. Everybody say bye. Ready?
Quit.
Go.
Quit.
Bye. It's going.
Quit.
Oh, that was weak.
Quit.